Hey guys, welcome to this video tutorial on how to set up a CNC horizontal machine. In this video, we will cover how to set up a multiple parts, how to nest the parts efficiently so that we can able to optimize the CNC programming output, able to increase the throughput and increase the yield. So if we can see on the screen, we have multiple parts arranged on a tombstone. So this is a CNC horizontal mill. Now, this is capable of doing a full 5-axis contouring, but we don't, for this particular operations, we don't need a 5-axis. All we need is a 4-axis. You can see multiple parts arranged in a tombstone. This is a tombstone, right? This is a 4-sided tombstone. Depending on the clearance you have on the machine tool between the spindle and the tombstone, you can make it as a 8-sided tombstone or a 6-sided tombstone. The setup we got right here is an ideal for a horizontal mill. We have 4-sided tombstone. So the way the parts are arranged, we'll go back and expand all the objects, expand all components. So you can see these are the parts that we have on the setup. Now, if you can take this as a side one, so you have operations first off on the phase 1. Again, first up on the phase 3. So what we will do here is we're gonna, on phase 1, this is the phase 1. Okay, so that's in the tombstone, we arrange the part such that we can able to do the this side of the part as in the first stop. So we'll be doing this, cutting out this pocket, cutting out all this radius fillets and whatnot. So there are 4 parts we'll be doing in the op 1. Now in the op 2, in phase 2, we'll be flipping the part and doing the back side of the part, whereby we'll be cutting out the pocket and we'll be putting the chamfer around it on the profile on the periphery. Okay, so this is like a 4. Here you can see the same clamping device used in all 4 phases. These are the jaws. Right, these are just simple step jaws, as simple as you can be holding it. And now, depending on if you're using a casting or forging with a different complex contours, you'll be doing a custom jaws. Now, let's say anyways, the setup we got, we'll go over what we need to do. Same thing, we'll be duplicating the setup on phase 3, and phase 4 and phase 2 will be doing the back side of the package. So, for example, if you do this up 1 on the part, the idea is to flip this part and put it over here to do the cut of this pocket and this cut out here. So let's look at how we set up that. Go back and set up the machining, how it's all the geometry set up. Now this is the main MCS. So the idea here is if you put that your MCS, that MCS is right in the middle of the tombstone, they'll be okay for the full 5-axis contouring. But since we need to be able to track these parts one at a time for the tool offsets, for the tool life and whatnot, it's better to keep it a local coordinate and machine coordinate system, whereby we can give it a G54, 55, 56. In a lot of these machines with the final control Siemens and Heidenhain, we have multiple offsets where we can go up to G54.1, P100, 200, 300 and up to 500. So anyways, there's no problem in having a number of work offsets. So let's give it an MCS. If you look at this for workpiece number 1, as it's loading up. So each MCS, the way I put it in, it's able to track it for the programming point. So this is the main MCS. You can see it's right in the middle of the tombstone, right? Okay, so we get it. And then if you go to the local MCS, it'll be right on the parts, right? This is the phase 1. Phase 1, part 1. You can see the Z-axis pointing towards the spindle. So the tombstone has to back up to go back to reference point on the Z-axis. Y-axis is the machine has to travel up to get it. X is the on your right hand side. So each MCS, for the local MCS, you can see that since this part, from this part, the way we arrange the part is, this part is mirrored right? So when you look at the relative point of the MCS, still to get to this get to these features, right? This bottom pocket here, the pocket is on the upside. The y-axis has to travel up, right? Here y-axis has to travel down, but relative to each other, the programming coordinate system will be the same y positive. It needs to move in y positive direction. You can see the y positive is pointing downwards, so on and so forth. Okay, so same way this down. You look at okay, so zx pointing away from the spindle, y up. So if you track this, I think you already might have guessed it, right? So the y axis will be flipped downwards, right? Okay, to mention this point. Okay, that's how it's set up. So all the MCS local coordinate system datum series are all arranged such that they are related to each other. So the idea here is to optimize the programming time. So we're gonna make the toolpath for just one part number 1 on the first job. We're gonna copy it to 2, 3, 4, then go back to phase 3, copy it to 5, 6, 7, 8. Then we'll do the toolpath just on the when we flip it over to do the backside on phase 2 up first part. We'll be doing the toolpath for the first part. Then we'll be copying and pasting it to the other parts. Okay, so you get the idea. Now we'll go back and start the programming. So to start the program, let's go back to the first part, MCS. You got the MCS. Okay, so create operation. Since there's nothing complex about these parts, I just took the simple part to effectively tell you how to program and optimize the CNC horizontal mills. Okay, let's go to the mill planner. Pick the floor wall with IPW. So we're going to be milling rough tool. Let's pick the 201004 end mill. So that's 32 millimeter end mill. Okay, this is the bigger end mill we need. Beefy, stronger end mill to go and cut a lot of material. Geometry. We're going to pick the MCS first part, right? Okay, all right. So method is roughing. So I'll be putting in all the models so that you can follow along. Follow the Google link where I will putting the models in. It'll be in a step format or Parasolid. So since we already have the geometry selected for the MCS, which is the geometry is this part, the wall geometry, we need to just take it off. We don't need it. So when you go to cut pattern, follow part, stay constant, 50% of the tool, depth per cut, let's get 5 millimeter at a time. Depends what are the operation you want. This is like a better to use the depth per cut. So now to specific cut area, we're going to select the first got them all. Okay, so now we're done with this operation. Hit OK. Okay, we got the first step done. So now you're gonna copy paste it. Copy, paste underneath it. Now we're gonna edit it to select the bottom face. Go into the cut area. Okay, take it out and select the new one. Hit generator tool. Apply the toolpath. Okay, that's about looks right. Hit OK. Now the idea here is to, once you've done all these toolpaths, copy paste into different geometry. Just all we're doing is just copy these two, right? Come underneath, paste inside, paste with reference. When you paste with reference, what's happening is you're keeping the dependent and independent objects. Basically, these are the workpiece number one, face one. Workpiece one is the master or the parent object. You're going to copy the objects underneath it and put it underneath the second object, so that becomes the child object of the parent. Okay, so you're keeping the association between the first and the second object. As you keep on going forth, all the objects, whatever you're pasting inside, will become the children of the parent object. So whatever you do to the parent object, it will be automatically updated as you do anything to the parent object. So what we got so far, guys, we got two roughing operations. So we will keep on now go back and rough the rust milling of the top packet and bottom packet. Then we'll come back and clean it with the profile cut. So we got two operations. So like you see on the screen, we are able to do it for the workpiece 1 and copy it down to workpiece 2. Now we got a roughing 1, the top side, the top of the packet, and then went there. So now let's do the rest of the operations. Create operation. Go back and select the different tool. Now this time we will select the mill 10 millimeter. Okay, so still we are in a workpiece 1, that's in the top one. So it's going to be, this time it's a mill semi-finish. Okay, so corners, we're going to go back and do the rust milling. Corner, rust milling. Little typo there. Fix that. Okay, now we got the cut area, wall geometry. Pull it out. Okay, so now we got to do the same thing. It's gonna be follow path, 50%. The non-cutting moves, since we're gonna be the rust milling, that means the material left by the main roughing operation, because of the diameter of the tool, now we are using a smaller diameter tool to go back and cut all the materials left by the main roughing operations. So now we need to, instead of ramp on shape, we can go and change it to now it's going to be in an open area. The we'll let's go back and change it to arc radius. Select 3% of the tool diameter. Now transfer and rapids are important. You want to keep the non-cutting moves, non-cutting time as low as possible, right? The main cost is in the main cutting area. So non-cutting moves is nothing but non-value added activity, right? So between regions and within regions, right? So we don't want the tool to retract all the way back into the clearance plane. So we just want to keep the between regions transfer within regions to be as minimum as possible. Same as within regions. Previous plane, safe clearance distance 3 millimeter. It's too much. That's about 2 millimeter, 80 thousandths. Clearance to axis, previous plane. Okay. Okay, now the tool overhang, we got to go and modify that. It's important, right? Okay, let's go to containment. Now cut regions, exact. The tool overhang, we may have to put it back to 100%. That means 100% of the tool diameter. The tool needs to travel, the cutting tool needs to travel 100% of the diameter beyond the material being machined, the IPW being the machined. IPW is the stuff that you're going to clean up, right? The main of operation. So you can see the step over and step down. That's highly critical when you're doing your roughing operations. Always watch out how much you want to step down for each pass. If you are cutting in different depths, so the step down is important. When you step over, that means what percent of the tool diameter you want to step over. Let me speed it up. So now you're seeing what you're seeing is the rust milling. So that means we're using a smaller tool diameter to go back and cut out the material that's been left by the bigger diameter tool. For roughing, you have to keep the tool life stable and make the tool material removal faster. We'll be using a beefy tools. For rust milling, we'll be using a smaller corner radius. Okay, it's all done. Looking good as we wanted. Now the remaining thing is, let's copy this, paste it. Now we're gonna keep that edited. This time we will deselect the top face and select the bottom flow. Cut area. Okay, deselect it. Select this. Okay. The other parameters, such as the containment that we changed in the cutting parameters, the non-cutting moves that we did, the engage, open area engagement of the tool into arc, the 50% of the radius of the arc. Let's keep it as it is. And the between, in between, and between region transfer. Where do you want to tool to retract before it changes to from one cut region to the next? Keep the same. Generate it. Okay, so now we got all 4 operations. So now what we need to do is we need to go back and clean that, do the planar cut to come up with that final clean area, right? So what do we need to do? What we need to do is we need to select the planar profile. What you can do is you can copy this, paste, rename it to, okay. We need to change that. First things first, let's change the tool to small diameter tool. That will be able to engage all the corners right. So it's going to be this. And what we need is instead of fall apart, we're gonna do a profile. Let's keep here 70%. So there's only one cut. The single planar pass on it. All right. Anything else? Looks good. Oh, I need to change it to mill finish. The parameter. Here, this. All right. Right, we got a nice planar cuts all around, as you can see. Okay, now we're done with that. Operations. Let's copy paste all of them. How much remaining? 3. Okay. Do the shift. Select the last one. Copy it. Paste it. Paste inside with reference so that you can, whatever you do, edit the parent object, it will be reflected to the child object. All right, so do the same thing over here. Copy it, shift, copy. So now we got here, paste inside with reference. So we got three things filled out. Now what we need to do is we need to select an MCS for this object. Let's double check it. So instead of okay, so this make it faster, right? Okay. So now we'll do the same thing.